Hi everyone, we are back and we are into problem 3 on our exam 1. Defects are awesome. A student claims that the integral of this first peak is 8. Is this true, and what material is this? So we have our PDF RDF, so we know that this first peak is 2r. This peak, if we're simple cubic or BCC or FCC, that's our second nearest neighbor distance. So for simple cubic, that's going to be 2r root 2. This is going to be 2r root 2 as well for FCC, and then for BCC, it's 4r divided by square root of 3. We are going to pull up Mathematica. I need to reinstall the updated version of Mathematica on this computer, but we are okay while we wait for that to happen. Waiting. Don't worry. There we go. All right, so let's go ahead and we can look at those relative ratios. So if we have, actually, we could just do, let's do the whole thing. 2 times r times square root of 2 divided by 2 times r. Let's do that numerically. But compared to 4 times r divided by square root of 3 equals the following. So 3.68 divided by 2.6. What material is this? Well, it could be simple cubic or it could be FCC. So the student is not correct. So what do we have to do? Well, I'm going to go to my periodic table. Then I'm going to solve. I know that 2.6 divided by 2, that's going to give me a 1.3. So I can do Control F. I want to look at 1.3. I want to look for metallic radii. None of these are metallic radii so far. Actually, we may do 1.30. Let me make it a little bit easier. Oh, chromium, but 1.3. That's telling us chromium. What is the material for chromium? That is BCC. So yeah, the student, this is a mistake, and again, we're actually not sure what this material is though. But we know from this, it is either simple cubic or it is FCC. It cannot be BCC because those ratios don't make sense. And we don't know what the material is. Great. Draw the RDF PDF of a gas. So gas would just be that flat line after your initial kind of, peak there. Liquid will have kind of something that looks like this and then ends. And a fully amorphous polymer can probably be a little bit sharper. Maybe it goes a little bit longer, but then it goes to 0. And there we go. Rank all these in terms of short range order, long range order. So they all have some degree of short range order, but for long range order, this is worst. This is, middle, fully amorphous. That's the best. Or in terms of long range order, the most long range order. Determine defects in the image below. Be sure to check each plane, see the dimensionality defect, show all steps in the Berger sector, blah, 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 blah. So these are all 1D defects because there is no defect in here, and we can kind of show that. And there's no defect here. There's no defect here. There's a kind of a defect here, but it's from here. So I'm going to do these are all line defects, dislocations, either edge or screw. I'm going to pick my tangent vector. So it is going to be, my tangent vector is going to be coming out of the board. So that's my first step, my T. My starting point, I'm going to do my start here. Let's go here. Let's actually go here. This is my start. So let me erase that quickly. Start. Yuck. Sorry. I'm trying to move my timer on my... There we go. So let's go back. So that's my start. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is going to be my finish. So again, I'm going right-hand, so I'm going in this direction because I'm going right-hand roll. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. And I do start to finish. This is edge. What about this guy? So I'm going to pick it, again, going kind of out of the board here. So where do I want to start? I want to start here. I'm going to go 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Again, sorry, I got to move my little. 1, 2, 3, 4. So again, this direction, this direction, this direction. 1, 2, 3, 4. And then, let's go ahead actually. 1, 2, 3, 4. 1. Actually, hold on a second here. My counting is giving me consternation. So I'm going to go here. This is my start. 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. So there we go. Start. Doosh, doosh, doosh. So I did 1, 2. I need one more. So that's my start. This is my finish. My start to finish. I was going out of the board for my tangent. So my burger parallel to tangent, that's a right-hand screw. And they're all 1D defects. Fantastic. Did this. Determine the defects in the image and state the dimensionality. Ooh, I like this. So these are all 0D defects that I'm going to be pointing out right now. Vacancy. This is a substitutional impurity. This is an interstitial impurity. This is a self-interstitial. And this, my dear friends, is an edge. 1D defect. Anything else? Nope. We're pretty good here. And that's it. That's all she wrote for problem 3. So we'll move on to the next problem, which is going to be our phase diagram. See you then. Thanks. Bye.